Everybody, welcome back to part 3 of the RecyclerView implementation. The very simple RecyclerView implementation. In the last episode, we created this simple adapter class that is going to control the simple view holder class. And if you missed that, I would definitely go back and take a look at it. This might just look way too confusing if you're just jumping in at this moment. So please go ahead and review that, get caught up to speed, and return. And for all of you who are just watching this in sequence, welcome back. Thank you so much for the continued support, and hopefully you are excited to get this going on screen. So, like I said in the last video, we are ready to go as far as this adapter class. There is no further implementation that we need to do right here that I can see right now. So we are going to go ahead and actually do something. So I'm going to go ahead and actually split this over here so we can see this code as well. And we created one function called SetData that actually requires a list of strings. And the reason we're doing that is because we essentially want to translate that into views on the screen. And so we're starting simple with just strings. So we're going to create a list that says data for adapter equals an array list of strings. Right? At this point, we've created a list, but there is nothing in. So let's go ahead and populate that, and we're going to do so in a for loop. However, instead of using the traditional for loop, we actually have an interesting way of accomplishing the same thing in Kotlin called repeat. And we pass in the number of times that we want this code to repeat, and then we pass in a lambda function at the end that will be invoked that many times. So let's start small. Let's go with 15. And let's get to the getting. Here we, again, much like the set on click listener, we have this lambda function here, and whenever there's a lambda function, the system, if there's only one variable that gets passed into the function, it just refers to it as it. However, we can actually rename this to whatever we want, and I'll show you how to do that right now. So basically what you can think of for this is actually an index. And so if you just name it here and then do this little arrow here, that means that now instead of referencing it as it in here, you reference it as index. And so this is super important moving forward. This is super important for, I guess, code readability, right? And when you're looking at it in the IDE, you can see that it says it and that it's of type int. But when you're looking at it, maybe, if you're just looking at the raw file somewhere, or especially if you're looking at it in a code review, you don't actually see that little like tooltip that comes up here, right there. You don't see that when you're outside the editor. So it's good practice to get in the swing of things, to actually be declarative and name these variables. And so not the end of the world, but something to note. So in order to add an element here, we're going to go ahead and do this. So in Java, you would traditionally have to create a string that says element, and then maybe put a space, and then do like a plus sign here, and then some other variable. But in Kotlin, you can actually just basically inline those variables into the string themselves, and so it just looks a little cleaner. It's a little I don't know, more intuitive, nicer. It's just like simple to see how the formatting of it is going to work out. You don't have to worry about where does that end quotes, where are they? Is there a space there? Is there not a space there? Blah blah blah. So it's just a simple, easy way to do that. And actually, if for whatever reason you had an object and you wanted to reference a field in the object, you can actually do $, squiggly brackets, and then let's say this was this was called person, and then you wanted their name, right? You could reference like person.name in there. If you need to do anything, any kind of a function call or anything more than just the actual field itself, you need to put these little brackets around it. But if you're just doing something simple like inserting an integer or a another string or a primitive type, you could just very easily pop it in there. Okay, so should be pretty straightforward. After this entire function, after this block runs, this data for adapter will have a list of strings in it, element 0 through 14. We all know that in programming world that the indices start at 0, not at 1. Yeah. So now we actually have our data that we want, and so we can create, we can now connect this adapter to our recycler view. So let's go ahead and get a reference to the recycler view. Perfect. So we now have our recycler view in code. We're going to create an instance of this simple adapter. Call it simple adapter. Wonderful. We're going to set this data that we have. The data for the adapter. And then in order to, in order to connect these two together, in order to notify this recycler view of the adapter, we do recyclerView dot adapter equals simple adapter. Boom. And so now this recycler view has an adapter attached to it and should lay out all this information. So let's give it a whirl. Let's run it. Huh. Well, that doesn't make much sense, right? I mean, we've set our adapter on our recycler view. We've set the data in our adapter. What's going on here? Why can't I see what, Remember when we were talking about in the last episode that the adapter, the system will at some point ask the adapter class, hey, how big are you? How many items do you have? And when it's created at this moment in time, it actually has 0 items in it. And then at some later point, we come in and we actually set the items. And so we will actually, now there are, in this case, 15 items that exist in this data, and we would tell the adapter to refresh, and all the views would come on screen. So we are missing that critical point. So if you actually call simple adapter notify data set changed, that will basically under the hood rerun, asking the adapter, hey, how large are you? How many, how many items do you have? And then if it is a non-zero number, it will actually go ahead and create the view holders and start to bind them as well. I'm leaving this open here because you can actually see there's just the overarching notify data set changed, which would basically invoke a refresh on the entire list. But there's also different functions here, right? So there's item changed at a very particular position, item inserted, moved, a range has been changed or inserted or removed, or a particular item has been removed. So sometimes this is actually, something that you will end up needing to do, where instead of refreshing the entire list, you just want to refresh a particular item in the list. Maybe there was user input that came in and it was specific to the 4th item in the list. So instead of telling the whole system or the whole entire thing to refresh, you can just tell it the exact element that it should refresh, and it will actually rebind that view holder with now hopefully whatever updated data you've supplied. But in this case, we are going from 0 to 15, and we don't have to worry about getting into those real fancy and high-end function calls that these that I'm referring to as these. So we're just going to do notify data set changed. And so now, if we end up rerunning this, Ah, that's right, that's right, that's right, that's right, that's right. Well, forgot one other thing. Um, we set the orientation here a while ago, right, to vertical so that it would go this way. However, we also needed to set something called a layout manager. And here they're actually going to have a few that are uh, defined for us. And so we will actually just go with the linear layout manager, which will actually just lay these things out in a linear fashion. If you saw some of these this other one here, or these other two are grid based. So you could probably imagine a few apps that have used grids in the same or instead of defining things in a linear fashion. But for our case, we're only going to need the linear layout manager because we just want them to appear one after another. So sorry about that. This is very important, as we can see. And now if we rerun things here, the system will actually know how to lay out all of these items that we've supplied. And you can see here, element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a little bit of 10 are defined in our list of data that we have here, that we have told them, this is how big it is, and so therefore when we're binding the corresponding position into the view, and you can actually scroll quite simply, right? There's a little, over scroll, as they call it, to kind of signify that you have reached the end of the list in either direction. And then if you were horizontally scrolling, you can also do that. You would also be able to see these overscroll things horizontally speaking. But that's about it. I mean, it's simple, it's small. Let's go ahead and change this to 150. So instead of 15 items, now we have 150 items, and yeah, you can kind of give it a fling. You can now see how we're kind of getting a window into the list and just kind of scrolling our way through it. And let's go ahead and beef it up a little bit and see how we do. Yeah, so I mean, you can very easily see here that it's scrolling relatively smoothly, and that's on an emulator, on a phone, on even a recent phone, it'll just breeze right through this. There's absolutely no problem, and that's because these elements here are on screen. There's probably a few other ones here that are outside of the view's bounds, a few that are down here as well, so that as you scroll, it already has those loaded and ready to go. They've already been bound, so you can kind of really accomplish that seamless scrolling that you're seeing here. And at this moment, there's really only one view type that we're worrying about, one layout that we've been working with here, and you can just very easily see that it's just replicated 1,500 times in this case. So not a super amazing layout, but or UI, but it most definitely demonstrates the power and the capability of the RecyclerView. Let's go ahead and make a few modifications, and I'll just show you real quick the grid layout. So I'm actually going to have this wrap content completely. Before we get to that, I'll just show you why we needed to change this height thing. Because you can see all the elements right there, one after one another. And if we have this layout here set to match parent, you only see one. And that's actually because the other one exists down here. So if you can actually imagine, this view here is matching its parent. This view here is matching the size of the recycler view that's defined here, right? This entire view. So scrolling through this would be an absolute nightmare. So that's why I said we need to make sure height is match parent. Sorry, his wrap content, so that it only takes up as much room vertically as it needs. But we would run into this same problem if we were to start scrolling this thing horizontally, and we had the width set to match parent. So let's go ahead and do wrap content. We're going to flip back here, and we're going to give it a grid layout manager, and then we're going to give it what we call a span count. And so you actually need to define this for sure, because otherwise I think it just defaults to 1, and then it just looks like a line. But the grid will actually, as it says, lay things out in a grid-like fashion with a particular span count that you have. So now you can see, oh sorry, wow, I flung quite far. Now you can kind of see how it works. You see that once the text starts to get too large and all 4 of these can't fit on the width of the screen, that now it kind of, the text begins to wrap. So grid layouts can definitely get a little bit more complex because you need to just manage a whole lot more stuff. But just know it's quite simple to turn a linear list into a grid. It literally requires no code changes. It's just the layout manager. So let's go back. Let's keep it a grid layout, but let's change it from vertical to horizontal and see how that looks. So now what that's done is, because the scrolling region is left to right, the span count of 4 essentially creates 4 rows of data in the available space that the RecyclerView provides, and then you can scroll left and right. And that's really difficult to read. But you can see the overscroll mode happening here when you reach the end of the list this way, and then yeah, we're still not even halfway there, so it's not even worth it. But trust me, if you go the other way, you'll also see the overscroll mode. While we're on that topic, it's actually an attribute. You can set it to never if you wanted to. So if you were to continue scrolling and trying to drag more, you don't actually see that little system UI thing that pops up. So in some cases it's useful because you kind of don't want to show the user that the screen is laid out in like a list fashion, but other times it's useful so that you let them know that, hey, that's the end. There's nothing more. So we'll leave that as is, and we'll go from there. We'll change this back to vertical. There's one more thing I wanted to show. If I can think about it really quickly, I will. Oh yeah, scroll bars. Just kind of going in with the little like UI of letting people know where they are. You see here on the side, you can put scroll bar, so now you understand where you are in the list. And if there were if there were a lot less elements, that thing would be larger. But it kind of fades in, fades out. So it's just a nice to have, and you can kind of see or understand when you're getting towards the bottom or the end of the list in one direction. So yeah, I think that's going to basically wrap it up. I'm happy to hopefully that you can kind of understand this simple adapter and how we've basically translated a list of strings into an entire UI here. And with some configuration changes in the XML, we get some pretty interesting layouts and some pretty interesting or powerful tools that we have here. And this is all done with just one single view type, and literally just a text view. You can imagine that this could scale to a recycler view of recycler views, and now you have a vertically scrolling list of horizontally scrolling items, and like the App Store application would provide. So there's so much that you can really do with this. You can see how easy it is to transition from grid to linear, and all of that we configured in the XML can actually also be done in code at runtime. So you can kind of allow your users to even say, oh, I want to see this in a grid fashion. No, I want to see it in a list fashion. vertical, horizontal, etc. Like you can kind of allow for all those tweaks as you wish. So this was hopefully a simple, easy introduction to RecyclerView. I think we're going to extend this now to maybe go back to just, the linear route, maybe not so many items, and work on a few other view types so that we can actually now start getting a list of elements that are different from one another, and then eventually build up to having a list of these items in our UI. So then we can kind of build somewhat of a feed, and then we'll kind of incorporate what we did before, where we can move from one screen to the next, and maybe this starts to turn into the list view, and as you click into it, you get the detail view and maybe some other information alongside of it. So thank you for sticking by. I'm happy that this only took 3 episodes to kind of at least lay the foundation, but we will continue on learning about the RecyclerView and all of its capabilities in the next episodes. So thanks. I'll see you there.